Yeah, this is another question from irodov on gravitation. So let's see the question. A cosmic body A moves to the sun with velocity v0 when far from the sun and aiming parameter L. So they gave that this length is L and the arm of the vector v0 relative to the center of the sun. Okay. They gave that these both are perpendicular and the length is L. Find the minimum distance by which this body will get to the sun. Okay. So yeah, here it is the sun, and it is when the planet is far away and it is having some v0 velocity and it is perpendicular to the sun with an impact parameter, aiming parameter L. Okay, and it will go like this, and it will be the distance x here. Let's take x. So okay, so it is having x and the final velocity it will be having, let's take it is as v and it is as v0. So they're asking the value of x. So x equal to what? This is what they're asking. So we have to observe. When we observe this thing carefully, they told that it is when it is far away from the sun. So when it is far away from the sun, basically they meant that it is coming from infinite distance. So when the distance is infinite, the potential energy of between the sun and the planet will be 0. gmm by 2x minus gmm by x, it will be equal to 0 because x is tending to infinity. When x is tending to infinity, it will be equal to 0. So yeah, initially the potential energy will be equal to 0. So if we write the initial energy of this planet, and sun is equal to half into m. Let's take this as equal to m. Mass is equal to small m and the planet is equal to capital M. M into v0 square. Yeah. At final position, the final position is this B and it is A. At final position, finally energy equal to kinetic energy will be equal to half into m into v final into square. Let's take this v is equal to v final and minus, also there will be some energy, gravitational energy between both of them, gm capital M into small m by x. So let's take this as 1 and this as 2. And also if we take we can conserve the momentum, angular momentum, because if we see it from the perspective of the sun, it is always a central force acting on the planet. So if we conserve the angular momentum with respect to sun, it will be conserved because there is no torque acting on that planet. So initially the momentum is equal to m into v into L, m into v into L initially. Finally it will be equal to m into this is v final and this is the distance x, v final into x. So if we cancel out both of them, v naught L equal to v final into x. So if we conserving angular momentum, m v naught L equal to m into v final into x. So here we can get v final equal to v naught into L by x. This is the third equation which we can equate. From conservation of energy, we can equate equation 1 equal to equation 2. So half m v naught square equal to half m v final square minus g m by 2x, no x. So we can take the gmm by x that side and half m into v final square minus v naught square. So we can cancel the m, 2gm by x equal to v final square minus v naught square. Keeping the v final square value here, 2gm by x equal to keeping this v final square value, v final value. So what is that we got? V naught into L by x whole square minus v naught square. So gm by x to 2 equal to v naught square. If we take common out, L square minus x square minus 1. Multiply both sides with x square, 2gm x equal to v naught square L square minus v naught square x square, v naught square x square plus 2gm x minus v naught square L square equal to 0. It's just becoming lengthy just because of the that's how problem is, because it's meant to be lengthy. It's just an basic math which we have to do. It's we got a quadratic expression which will get two roots, and one of them will be negative and one of them will be positive, and the positive one will be the answer. So let's just solve it. X equal to minus b, 2gm plus or minus, so let's just take the plus, under root b square 2gm whole square b square minus 4 into v naught square 4ac minus v naught square into L square by 2 into v naught square. So x equal to minus 2gm plus under root 2gm whole square plus 4 v naught power 4 L square divided by 2 V naught square. So basically this is the shortest distance between the planet and the sun when it is passing, and this is the answer we want.